Okay, good afternoon, everybody. So, after a lot of delay, we start our class today. Unfortunately, due to heavy rains or for some reason, the place where we take classes, the internet was dysfunctional today, so we could not take classes today. But the IT team was very supportive, so they managed the class today here at Council Hall. I thank them for their prompt response today. And so, thank you that we could at least save some time for today's class. So we shifted all the way from there to here, and then we start the class here at Council Hall, HBNI. And so we continue our classes on research methodology, research and publication ethics. This being conducted under the auspices of Homi Bhabha National Institute for the research scholars and as well as other students who are interested. And we have carried out a lot of classes till now, where Remia Madam is taking classes, Kallul sir is taking classes, and I took classes on research methodology introduction, that is in module A, and module B we have covered more than half, and we are in the research design stage. And also we have been mixing right now, all these will go on parallelly. So we did something on experimentation as well. We did a lot on randomization and replication experiments, and then proper approaches we'll discuss today as well as the remaining of the research design. So we carry on. So just a recap of what we did last day, that is important concepts relating to research design. So we did what is dependent and independent variables, and then a very important term. These are important terms because these will continue in our present classes and the future classes as well. And we defined a term known as extraneous variable, right? So what are extraneous variable? We defined it as independent variables that are not related to the purpose of the study, but may affect the dependent variable of the study, are termed as extraneous variables. So what is a good study? A good study was one which is so designed that the effect upon the dependent variable of the study is attributed entirely to the independent variable of the study and not to some extraneous or external variable, right? So your study should be free from extraneous variables, right? Means one which modifies some external factors which modifies your dependent variable of your study. And so we define the term control experiments. So the technical term, how we define control is the control experiments are used when we design the study minimizing the effect of extraneous independent variables. Okay. So in experimental researches, the term control experiment is used to refer to restrained experimental condition. So extraneous variable and the control experiments are one which is independent of manipulation from extraneous variable, right? And we defined what is confounded relationship. We explained in entire class on research hypothesis. We defined what are experimental and non-experimental hypothesis testing research with the help of a very nice example in which 50 students, the intelligence and the reading ability were correlated and under non-experimental hypothesis testing research. And if we divide those 50 students into two groups, Group A, 25 students, and Group B, 25 students. Group A assigned to the usual studies program and Group B assigned to the special studies program. And then if we try to judge or find the correlation between on the independent variable, that is a type of training program, is manipulated and then its effective studies, means depending upon the type of training program, usual training program or the special training program, and what effect it has on the outcome of the study, then we termed it as experimental hypothesis testing research, because in this you are conducting an experiment where the independent variable you are manipulating, right? The studies program. Okay. And then we define the term experimental and control groups. So in this Group A is the control group because it is doing the usual studies program, and Group B the experimental group because it is doing the special studies program. So control groups are those which are exposed to usual conditions, and experimental groups are those which are exposed to special conditions. And then we define the technical term treatment. The different conditions under which experimental control groups are put are referred to as treatments, right? So in an experiment, we do a treatment, okay, to a group. And then we defined what is experimental and experimental units in details. So what are experiments? So the experiments are those, the process of examining the truth of statistical hypothesis relating to some research problem is known as experiment, right? And we went on the effect of on the different types of study, the exploratory or formulative study, descriptive and diagnosis study, how the research design varies, and research design also we studied in the case of hypothesis testing research. Okay, and then we defined and explained in details the three basic principles of experimental design. What are the three basic principles? The principle of replication, the principle of randomization, and the principle of local control. So we defined all these three in details, and we explained what are those. So in replication, then randomization, and the principle of local control. So then we did what are the steps in sample design and what are the characteristics of the good design. So the sample design must result in a truly representative one. The sample design must be such which results in small sampling error. Sampling design must be viable in the context of funds available for the research study. Sample design must be such so that the systematic bias can be controlled in a better way. Sample should be such that the results of the sample study can be applied in general for the universe with a reasonable level of confidence. So these are the 5 characteristics of a good sample design. Here we ended, means concluded our previous class, and we continue on research design as well as experimental design, means experimental design, the experimental part of research design. So in general, what are the important experimental design? So there are broadly, you can classify the design into 2. What are those? The informal experimental design and the formal experimental design, right? So what are informal experimental design? Informal experimental design can be divided again into 3 parts, 3 types: before and after without control design, after only with control design, before and after with control design. So this is these are the 3 different informal experimental designs. And then we will go on to formal experimental design, which are of 4 types, right? 4 types of important experimental formal designs, which are completely randomized design, randomized block designs, Latin square designs, and factorial designs. So we will just cover in brief, means we will define them, and then just in brief we'll study, try to understand what are these. So just try to concentrate and just simply try to know what are the different types of important experimental designs and their basic characteristics. That's the fundamental basics, not in details. So before and after without control designs. So this is we'll define these 7 types. The first, the informal experimental design, 3 types. We'll define and describe in brief one after the other. And then we will go to formal designs, the 4 types of formal design. So first, we come to before and after without control design. So this is one part of informal experimental design. So it is informal, as you can see, it's very simple, right? This is the simplest type of design, experimental design that one can make. Comes under informal and very simple. So we define how we define this. In such a design, a single test group or area is selected. So as we are defining, means from the beginning of research design, we are try to do the case studies for agricultural land, right? Most of the time we have covered agricultural land. So here also generally the research design refers to such areas. So in such a design, a single test group or area is selected. So here only a single test group is there, right? Only one. And the dependent variable is measured before introduction of the treatment. So we defined several terms last day, and we have come under, means we have just recapitulated today. extraneous variable, control, experimental and control group, treatments. So we define what is treatment in terms of technically, that treatment are the different conditions under which the experimental and control groups are put to. Okay, so you are varying the conditions of the experiment. So you are introducing the treatment to one group only, a single test group, right? Not two, not into control groups and experimental groups. Just a simple, in a single test group, you are introducing the treatment, means you are trying to modify the variables. The treatment is then introduced. So before introduction of the treatment, okay, you measure the dependent variable. Okay, first work you do. So there is a test area here, there is a test area, and before introduction of the treatment, just before that, level of phenomena before treatment X. Okay, you measure the phenomena before the treatment. Say you all do this. I will come to you. This back. The treatment is then introduced. Then you introduce the treatment to that area, test area, and the dependent variable is measured again after the treatment has been introduced. So you introduce the treatment, means modify it, and then again measure the same phenomena. Okay, and you measure then the level of phenomena becomes Y. So the treatment effect you defined as Y minus X. So the effect of the treatment would be equal to the level of the phenomena after the treatment minus the level of phenomena before the treatment. So this is how you, before and after, without control, you do the experiment. So this is type of experimental design where the design is without control and you measure the phenomena before and after the treatment. Okay, on a single test area without control. Why we are telling without control? Because the main difficulty of such a design is that with the passage of time, considerable extraneous variables may be there in this treatment's effect. So with time, there can be external factors which can affect the value of this phenomena. So the value of this phenomena is not only dependent on, means the value of the phenomena means the value of the dependent variables is not only dependent on the independent variable, but with the passage of time, it will depend a lot on the extraneous variable, right? So this type is the simplest design, but here it is subjected to modifications by external variables, extraneous variables. So before and after without control signs. So this is the simplest design, but not foolproof design, but it is simplest to start with. Everyone, so what we do in our catalyst experiment, I always go to the materials. So we have a catalyst. So we measure the activity, okay? So before introduction of the catalyst, we measure the activity, and after introduction of the catalyst, we measure the activity. And the differential activity, we say that it is due to the introduction of the catalyst. But there are so many factors, kinetics, thermodynamics, the temperature effects, the mass transfer effects, so many extraneous factors we are ignoring. So we have to take into, if we only do the intrinsic catalysis, then we can say, okay, it is free of extraneous variables. But such a simplest design, such a simplest experimental design is not free from the treatment effect or extraneous variables. So this is simplest, but not foolproof. Then we go a step ahead. This is also informal. This is also not so exotic, but still we should learn, because these are definitely experimental designs. But we should know that it is subject to change due to some extraneous variables. So what are after only control design? So here the design is control, okay? As we define the control experiment, which is free, try to be free from extraneous factors or extraneous variable. In this design, two groups or areas, test area and control area, are selected. And the treatment is introduced into the test area only, okay? So the treatment is introduced only the test area or the experimental area, and the control area is not subjected to the treatment. So here there is a test area, treatment introduced. Control area, treatment is not introduced. The dependent variable is measured both in both the areas at the same time. Treatment impact is assessed by subtracting the value of the dependent variable in the control area from its value in the test area. So the test area was subject to treatment and you measure the level of phenomena Y. The control area is subject to the same treatment and you measure the level of phenomena Z. So the treatment effect, you define it by Y minus Z. Okay, treatment introduced minus the one which is treatment is not introduced. Here it is a step ahead. Why? I'll let you know why. The basic assumption in such a design is that the two areas are identical with respect to their behavior towards the phenomena considered. Okay. If this assumption is not true, so first we are making an assumption. What is the basic assumption? Is that in such a design is that the two areas are identical with respect to their behaviors towards phenomena considered. So the phenomena or the dependent variable you're measuring, the behavior of the two areas are similar. Okay. If this assumption is not true, there is a possibility of extraneous variation entering into the treatment effect. Okay. However, data can be collected in such a design without the introduction of problems with the passage of time. So the previous one was subjected to extraneous variable effects with the passage of time. Here it is free from extraneous variable effect with the passage of time. In this respect, the design is superior to before and after without control design. Okay, so here it is more rigorous because you are considering two test areas, one test area and one control area. Treatment is subjected only to the test area and treatment is not subjected to the control area. But with time, the extraneous variable effects are subjected to both of them. Okay, and so whatever results we get is more or superior to one we described in the previous slide. Okay, and then we come to the third and the final informal design, which is before and after with control design. So this is the third type of informal experimental design, that is before and after with control design. So this was also control design. This was not a control design, the first one without control design, before and after. This was control design. After all, you measure the phenomena only after the subjected of the treatment. Here what you do, you can understand before and after, but it is also under control. So we explain what it is. In this design, two test areas are selected. So in the previous one also, we selected two test areas. In the first one, we selected only one test area. Here there are two test areas, one test area and one control area. And the dependent variable is measured in both the areas for an identical time period before the treatment. So initially, before introduction of the treatment, in both the test area and the control area, for a selected time period, the level of phenomena is measured. Okay, in both these, in the test area and the control area, for a selected time period, before the introduction of the treatment, the level of phenomena or the dependent variable is measured. Okay, in both of them. The treatment is then introduced into the test area only. Then the treatment, as in the previous case, is introduced into the test area alone. The treatment effect and the dependent variable is measured in both for an identical time period after the introduction of treatment. So initially, before the introduction of the treatment, for a specific time period, you measure the phenomena in both test area and control area. And after introduction of the treatment, you measure the effect of the phenomena both in this test area and control area with the treatment introduced only into the test area. So in the test area before introduction of the treatment, if the level of phenomena was X and after treatment was introduced, then the level of phenomena was Y. Then in the control area, before the introduction of treatment, the level of phenomena was Z, and there was no treatment introduced into this phenomena. But after the treatment was introduced into test area, the measurement of the dependent variable was carried out over the same time period too as with test area, and we get that the level of phenomena was Z without treatment. Then the treatment effect is Y minus X minus Z minus A. This design is superior to the above two designs for the simple reason that it avoids extraneous variation resulting from both passage of time and from non-comparability of the test and control areas. Okay, so in the first one, with the passage of time, there was effect from the extraneous variable. In the second, with the passage of time, there was no effect due to introduction of external variable. So with the passage of time, it was superior. But here it is much more superior, because here we measure the two areas only after the treatment is introduced. But here we measure the phenomena before introduction of the treatment in the test area for both the cases, and after introduction of the treatment in the test area for both the cases, in test area as well as the control area. So here we remove the extraneous variable manipulation on the dependent variable from the passage of time, and also from non-comparability of the test and control areas. So previous slide, we were unable to compare the test and control areas, but here we are able to compare the test and the control area, the comparison, because we have measured both before introduction of the treatment in both the cases. Okay. So we now go into the more complicated ones. So these three are very simple, informal experimental designs, but and all those who are doing experiments, I'm sure you will be using such designs for simplistic cases, but formal designs are more rigorous. So we go into the first one, the completely randomized design, or the CR design. So we try to understand what is completely randomized design. Okay. It involves two principles. What it involves? Two principles is the principle of replication. So if you remember, if you recall in the last class, as we have recapitulated during the initial initiation of today's class as well, that there were three principles of experimental designs. Okay. What were they? The principle of replication, the principle of randomization, and the principle of local control. So here, the complete randomized design involves only two principles, the principle of replication and the principle of randomization of experimental designs. Okay. The essential characteristics of the design is that subjects are randomly assigned to experimental treatments or vice versa. So what is the characteristics of this completely randomized design, or the CR design? It is involving two principles, replication and randomization principle. And also the characteristic of the design is that the subjects which you are studying are randomly assigned to the experimental treatments. Okay. So we defined experimental treatments as well. And here we are subjects are subjected to experimental treatments randomly. Okay. So what does that mean? It means that if we have 10, means we do a case study, simple, if we have 10 subjects, so we are going to study 10 subjects. And if we wish to test 5, and we will test 5 subjects under treatment A and 5 subjects under treatment B. The randomization process gives every possible group of 5 subjects selected from a set of 10 an equal opportunity of being assigned to treatment A and treatment B. So you have 10 subjects to study, and okay, and you want to assign 5 under treatment A and 5 under treatment B. It is not that if we list the subjects one after another, the 1 to 5 numbers will be subjected to treatment A and 6 to 10 numbers will be subjected to treatment B. In the completely randomized design, it is not like that. So it's not that 1 to 5 is treatment A and 6 to 10 is treatment B. Instead, what is there in the treatment of randomization? That every possible group of 5 subjects selected from a set of 10 an equal opportunity of being assigned to treatment A and treatment B. So both subject 1 can be subjected to treatment A or treatment B. Subject 2 can be subjected to treatment A or treatment B, and so on. Any subject from 1 to 10 can be subjected to either treatment A or treatment B, any one of them, based on principle of randomization. Okay. So here we introduce the term, I think already you have covered in the previous classes, I don't know, because one-way analysis of variance or one-way ANOVA. Okay, so analysis of variance, ANOVA, analysis AN of O variance, VA, ANOVA. So one-way ANOVA is used to analyze such a design. So this completely randomized design comes under the analysis of one-way ANOVA, or one-way ANOVA you use to analyze completely randomized designs. Okay, even unequal replications can also work in this design. It provides maximum number of degrees of freedom to the error. Such a design is generally used when experimental areas happen to be homogeneous. Okay, so if the test areas you want to survey are homogeneous, then you subject it to one-way ANOVA or one-way analysis of variance, means analysis of the variables you do, and you subject it to principle of replication or principle of randomization, and we state that the study is completely randomized design or CR design. This is one type of experimental design under formal experimental design. Okay, so there are two types of completely randomized design. So we define the first type, two group simple randomized design. In a two group simple randomized design, first of all, the population is defined, and then from the population, a sample is selected randomly. So initially what we do, you define a population, and out of this population, like the 10 subjects as we told, okay? So this is the population, and out of this you randomly select from 1 to 10, any 5 you select, okay? And you form your sample, the 5 which you want to study, okay? So from the population, you randomly select the samples. Two groups we selected of 5 each, 1, 3, 8, 9, 10. That can be your order, the subject number. So in a two group simple randomized design, first of all, the population is defined, and then from the population, a sample is selected randomly. So you select it randomly. Further requirement of this design is that items, after being selected randomly from the population, be randomly assigned to the experimental and control groups. So any 5 out of the 10 subjects which you have selected in our experiment, okay, any 5, you have divided into two groups, any 5 you consider as the experimental group and any 5 as the control group, okay. So this is random selection and random assignment. So first from the population randomly select, and second from the sample, two type of sample, you randomly assign 5 into one experimental group and the other into control group, okay. Such random assignments of items to two groups is technically described as principle of randomization. If you remember, such random assignment we call as the principle of randomization. And then what we do, we subject it to treatment A or treatment B. So one, the experimental group, we subject to a treatment, okay. So both of them we subject to a treatment. The experimental group is subject to a treatment and the control group is subject to a treatment. And we measure the independent variable. Thus, this design yield two groups as representative of the population, okay. And then random replication design. So this is more complicated. So we'll discuss this more, but just we introduce this. In next class, we'll discuss it more. The limitation of the two group randomized design. So what is the limitation of this two group randomized design? Here we are considering means dividing the whole population into random sampling and then random sampling into two groups of random assignments, only two, right? Two group, simple randomized design. So there is a problem. What is the problem? There is a limitation. So limitation of the two group randomized design is what? Is usually eliminated within the random replication design, okay? In random replication design, so here whatever elimination is, whatever limitation is there in the two group, we eliminate in this random replication design. How? In random replication design, each repetition is technically called replication. Random replication design serves two purposes. It provides controls for the different effects of the extraneous independent variables. And secondly, it randomizes any individual differences among those conducting the treatments. So this is more acceptable and minimal effect to the extraneous variables. Okay, so we introduced today few terms, but what are those? The informal experimental design, which are simpler experimental design, and we started from the simplest and went to do more rigorous within the informal ones, and then we introduced the formal experimental design, which is completely randomized design, where we introduced the two-group randomized design, the principle of ANOVA, and then random replication design. Okay, and then in the next class we'll go on to do the randomized blocks design, Latin square design, and factorial design. So we started late today, so we could not complete. Otherwise, I should have completed these. Only 4 or 5 slides were there, and but okay, I will send you these. Come prepared for the next class. Just read it. And this is the assignment. Any two out of this, all these. What are the different types of design? Just study any two. Informal experimental design is already covered today. Random replication design we have covered today. Two-group simple randomized design we have covered today. So you can answer any two out of these 5 today itself. We'll cover simple factorial design and Latin square design in the next class. We could not complete because we started late because of a technical error in the other place. But I thank the IT team that they could manage the class here today. And thank you all for being patient and waiting for the class. And sorry for being unable to do out of our means, unable to take the complete card, but due to conditions beyond our control. Okay, so we'll continue. We'll cover this in the next class and continue with models and other experimental design part. Okay, thank you. YouTube में चल रहा था वो